Hello children, today we shall start with the fourth chapter, that is structure of an atom. In this chapter we will see the various stages and developments in discovery of the atomic particles. So let's start. The discovery of atom was in the 6th century started or initiated by Maharishi Kannad, our very own Indian scientist and philosopher. According to him, matter is not continuous. Matter is made up of tiny particles called parmanus. Two or more parmanus combine to form bigger particles. So this was very early in the 6th century that somebody had done some kind of a work on discovery of the smallest particle. That was called the atom. Parmanu in Sanskrit means atom. Later in the 5th century BC, Democritus and Leucippus also talked about something called as atomos. According to them, on dividing a piece of substance, one will ultimately get a particle that could not be further divided. And they called it Atomos. So nearly about 2000 years after that, Dalton in 1803 came up with his atomic theory. According to Dalton's atomic theory, all matter consists of indivisible particles called atoms. So according to him, all matter consisted of very finely the smallest particles which were called atom, and these atoms could not be further divided according to him. The next point he made was atoms of the same element are similar in shape and mass but differ from the atoms of other element. So when you're talking of one particular element, all its atoms are similar. But if you talk of another element or another substance, then that time that substance is made up of, a different substance will be made up of different kind of atoms. According to Dalton, atoms cannot be created or destroyed. The next point he put forth was atoms of different elements may combine with each other in a fixed, simple whole number ratio to form compounds. Like very simple, like example of water, carbon dioxide, H2O, so hydrogen and oxygen are in simple whole number ratio, so H2, so 2 times of hydrogen and 1 time of oxygen. Or carbon dioxide, CO2, 1 part of carbon and 2 parts of oxygen. So atoms of different elements may combine with each other in fixed, simple whole number ratios to form compound. Atoms of same elements can combine in more than one ratio to form 2 or more compounds. So atoms of the same elements can combine in more than one ratio to form 2 or more compounds. Let's see example of carbon monoxide and carbon dioxide. In carbon monoxide, the ratio is 1:1, CO, carbon monoxide. Whereas in carbon dioxide, it is CO2. So the ratio is 1:2, 1 part of carbon, 2 parts of oxygen. So atoms of the same element can combine in more than one ratio to form 2 or more compounds. This was according to Dalton's theory. And the last point that he made here was the atom is the smallest unit of matter that can take part in chemical reaction. So whenever a chemical reaction is taking place, the smallest part that is taking place in this reaction is called as an atom. That could possibly be taking place is atom. Later, the modern theory brought out that atoms were divisible. So Dalton's theory was proved that it was not up to the mark and there were more research done. Now what were the subatomic particles? It was discovered that an atom consists of a positively charged proton, which is in the nucleus, that is the center of the atom. It has around the same size of a particle called a neutron, which is electrically neutral, does not have any charge. and it has very tiny particles with a negative charge that's placed in the orbits and is continuously moving around the nucleus. These particles were termed as electrons. Let's see how these discoveries took place. First, with the electron. So electron, as we discussed, is a very tiny particle and it carries a negative charge. It's moving in the orbits of an atom. How did they come to do this discovery? So this discovery was done by J.J. Thomson using the cathode ray tube. So a cathode ray tube was taken in which one side end contained a metal sheet called the cathode and the other end had an anode. And a vacuum tube was present, or an exhaust tube, exhaust pump was present in this, so that whichever gas is present inside the tube, whichever gas is allowed in this discharge tube or cathode ray tube, can be brought at a very, very low pressure. So a very low pressure is maintained and a very high voltage of electricity is given. So when a high voltage of electricity and very low pressure is generated inside a cathode ray tube, the cathode starts emitting cathode rays. So from the metal plate or from the gas which is present in the discharge tube does not generally carry current. But once the pressure is lowered and a very high voltage is given, at that time the gas separates into the positive protons and negative ions, that is electrons, and the electrons start moving from the cathode to the anode. So in this way a gas can carry current only under a very high pressure, under a very high voltage and very, very low pressure. It looks something like this in real life, a cathode ray tube. Once the cathode rays are generated, it gives a fluorescent light. So let's see what are the characteristics of cathode rays. The cathode rays originate from the cathode and they travel in a straight line. So the first important point is these rays travel in a straight line. Next, the cathode rays are a stream of particles. So they are basically a stream of particles. And which are the particles? They are negatively charged particles. Those were later termed to be as electrons. So if there is any object that is in the path of this, it can always create a shadow. If there is an opaque substance kept in the path of these cathode rays, a shadow is formed on the screen. It was also noted that the particles constituting of the cathode rays are negatively charged. They did deflect to electric and magnetic field. So if in presence of electric field and magnetic field, this fluorescent light, the ray, it shows a bend like you can see on your screens now. Here also we can see how the light is bending. The next particle that was discovered was the proton. An atom, as we know, it is electrically neutral. But now we have discovered that the electrons that have negative charge were present in the atom. So if an atom has to be electrically neutral, that means there has to be some positive charge inside also present to neutralize the negative charge. And thus the discovery of proton was done with the help of anode rays. So what are anode rays? In the anode rays, the cathode which was taken was perforated. Perforated means in the holes were made in the cathode. And the same kind of a thing, once a gas is passed into the discharge tube, it's connected to a very high voltage. At that time, it was noted that there were some particles that could move through the perforations of the cathode. And it was found to be that they were positively charged. We know that cathode is connected to the negative terminal of the battery and it had the attraction or it had the pull for the positively charged particles coming through it. And these gave a fluorescent light on the screen. So what are the properties of these anode rays? The anode rays are a stream of positively charged particles. So these are the stream of positively charged particles. In cathode rays we had seen they were negative particles, here they are positive particles. The particles consisting of anode rays differ with the gas used in the tube. Now, the anode rays were generated with the positive charge present in the gas. When the gas undergoes decomposition and some positive charge is present, those are the protons basically, they constituted of the anode rays. So naturally the size of protons will differ from element to element, and that is why with different gas used in the tube, the different particles would be formed. So it would differ with the particles, but whereas when we take cathode rays, no matter whichever gas you take, the cathode rays particles were just the same. So what are these anode rays? Anode rays consists of cathode rays which must come from the atoms of the gas which are in the discharge tube. Electrons are negatively charged particles, so the atoms must be left with the equivalent amount of positive charge. It is this positive charge that constitutes of the anode rays. So if there is a gas, that's a neutral gas atom which is not having any charge, when it will separate into electrons which are negatively charged, so at that time what will remain is some kind of a positive charge inside. So this is what is the anode rays, or this is what is consisted in the anode rays. So let's see the details for proton. What is the charge on proton? It is taken as a unit positive charge. A proton is taken as a unit positive charge. The mass of a proton is same as that of a hydrogen atom, that is 1 unit. A proton is about 1840 times heavier than that of an electron. So proton is positively charged, and the weight of a proton is taken as 1 unit, 1 atomic unit, or it's also compared to that of 1 hydrogen atom. And why we compare it with hydrogen atom? Because hydrogen atom consists of 1 proton and 1 electron. And as we discussed, that electrons are very negligible because they are about 1 upon 1840 times of that of a proton. So it is negligible, and that's why we compare a proton to a hydrogen atom. The next particle is the neutron. So neutron has no charge, it is electrically neutral. Electrons are negatively charged, protons are positively charged, and here we have one more particle that has no charge, that is electrically neutral, and it's the neutron. The mass of a neutron is the same as that of a proton, so it's comparable to that of a proton, and it's also taken as 1 unit. So it is also taken as 1 unit or as that of a hydrogen atom. So the protons and neutrons are of more or less the same size, but the electron is negligible in mass or in size. Discovery of the nucleus. So once all the particles, protons, electrons and neutrons were discovered, then it was discovered that there is some kind of a spacing. It's not a spherical ball or something with some embedded, because there were many different scientists who gave different kind of theories. Like Thomson had given a plum pudding method. So he said that all the positive charge may be present inside, all the negative charge may be present inside a positively charged atom. But that was found to be, it's not true like that. Then Rutherford came up with his alpha particle scattering experiment. Through this experiment, a source of alpha particles was generated, and it was made to hit on a thin gold foil. This alpha particles, some of them went straight without any deflections, and some rays were deflected. Some rays were deflected. On the fluorescent screen, we could see that the rays are deflected. Diagrammatically, it was something like this. So what happened is some rays could pass through and some rays were deflected. So whenever it came across a particle, a subatomic particle, it was deflected, and if it was within the space, it went through. This proved that there were spaces present inside the atom. Later, Niels Bohr came up with a theory of or structure of a atomic model, which he said the atom structure is comparable to that of our solar system. Just as the sun is in the center and the planets rotate or revolve around it, in a similar way, around the nucleus the electrons rotate. So this was Niels Bohr's atomic model. This is same model in 3D structure. As per the final modern theory of atom, some important concepts that we have to see now, and the first one in that is atomic number. So what is an atomic number? Please remember, atomic number is represented by the alphabet Z, and it is the number of protons. It is the number of protons in the nucleus of an atom. It is the number of protons in the nucleus of an atom. So when hydrogen has 1 proton, its atomic number is 1. Helium has 2 protons, its atomic number is 2. Lithium has 3 protons, so its atomic number is 3, and so on. The next is mass number. The mass number is the total number of protons and neutrons in a nucleus. That is, number of protons and neutrons in a nucleus is the mass number of a particular element. The mass number is represented by the alphabet capital A. So we have the mass number that is represented by A. So A will denote the number of protons plus the number of neutrons in a particular atom. Now, how are the electrons arranged in the orbits? Now we know electrons are arranged in orbits. These orbits are also called as shells. So the first shell is called the K shell. That's the innermost shell. It's numbered as the first shell and it is called the K shell. The second shell is called the L shell. The third shell is called the M shell and the fourth one is called N. So it goes on K, L, M, N, O and so on. There is a electronic configuration rule that is to be followed when we put electrons into the orbits. So the electronic configuration rule is 2n square. 2n square. And what does that mean? That is in the first orbit, when n is equal to 1, so n square is also 1, so 2 ones are 2. So we can have only 2 electrons in the first orbit. As per the rule, what is the value for the second shell? That is the L shell. When n is equal to 2, 2 square is 4. So 4 2s are 8. That means second shell, that is the L shell, can have 8 electrons in their outermost orbit. And so on. So the third shell will have 18 electrons, fourth shell will have 32 electrons and so on. So it goes from 2, 8, 18, 32 and so on. But there is one more rule to this. The first rule is 2n square and the second important rule is that we cannot have more than 8 electrons in the outermost shell. So in the valence shell, in your valence shell or outermost shell, we cannot have more than 8 electrons. And there's one more rule that we cannot have more than 18 electrons. We cannot have more than 18 electrons in the penultimate shell. In the penultimate shell, that is the second last shell. So now let us see the electronic configuration with example of sodium and potassium. So sodium has an atomic number of 11. Atomic number is 11. So what is its configuration as per the 2n square rule? That is, first orbit will have 2 electrons, second orbit can have 8 electrons. So we are left with one electron. But this one electron cannot be placed in the second shell itself. And hence it is carried forward to the third shell. So in case of sodium, its electronic configuration will be 2, 8 and 1. Next, let's see the example of potassium. Potassium's atomic number is 19. It is 19. So if we place as per the 2n square formula, first shell will have 2 electrons, second shell will have 8 electrons. Now we are left with 9 electrons and the capacity of the third shell is 18 electrons. But why don't we place all the 9 in the third shell? Because our rule number 2 says we cannot have more than 8 electrons in the last shell, and hence the electronic configuration for potassium will be 2, 8, 8, 1. 2, 8, 8 and 1. Now let's see a few structures. Let's see atomic structures of few elements. To start with, let's see hydrogen. Hydrogen is an atom which contains 1 proton and 1 electron. Hydrogen does not have a neutron, but some of its isotopes do have, which we will see in the next classes. But generally, the largest abundant element or abundant isotope of hydrogen is the one that has 1 proton and 1 electron. Next comes carbon atom. Carbon has an atomic number of 6. It has atomic number 6. What does that mean? It has 6 protons and 6 electrons. It has 6 protons and 6 electrons. It also has 6 neutrons. So we show 6 electrons and in the orbits that rotate around. So its electronic configuration comes to 2 and 4. It comes to 2 and 4. That's the electronic configuration for carbon. And all the protons and neutrons are in the center of the atom, that's called the nucleus. So that nucleus consists of protons and neutrons. So that is 6 protons and 6 neutrons for carbon. Now let's see the example of nitrogen. The atomic number of nitrogen is 7. So nitrogen has 2 electrons in the first orbit and it has 5 electrons in the second orbit. The diagram here shows 2 energy levels, but you just have 2. This is all, one second. Yeah, this thing should just be 1 orbit here. There are no. So the structure of nitrogen is, you have the first shell and you have the second shell with just the nucleus in the center. There are 2 electrons in the first shell and there are 5 electrons. 5 electrons in the second shell. So 5 electrons in the second shell and 2 electrons in the first shell. Nitrogen has 7 protons and 7 neutrons as well. Oxygen. The atomic number of oxygen is 8. The atomic number is 8 and its electronic configuration is 2, 6. So the first shell has 2 electrons and the second shell has 6 electrons. So oxygen has 8 electrons. So first shell has, that the K shell has 2 electrons. We see that here and here. And the second shell has 6 electrons. It has 8 protons and 8 neutrons. So it has totally 16 nucleus particles, 8 protons and 8 electrons in the center. The next we will see is the structure of sodium atom. Sodium, as we already discussed, sodium has an atomic number of 11. It has atomic number of 11. So it has 11 protons, 11 neutrons. Sorry, it has 12 neutrons. Sodium has 12 neutrons and it has 11 electrons. It has 11 electrons. So 11 protons, 12 neutrons and 11 electrons. Till now all the atoms that we have seen, they had the same number of protons and neutrons. In case of sodium, number of neutron differs. It is not necessary that every element has the same number of proton and neutron. The number of neutrons varies in various elements. Okay. So the electronic configuration we already discussed for sodium. That is what? That is 2, 8 and 1. So 2 electrons in the first shell, 8 electrons in the second shell and 1 electron in the last shell. That is also called the valence shell. Now let's see structure for chlorine atom. The atomic number for chlorine is 17. Chlorine has 17 protons and 17 electrons and it has 18 neutrons. It has 18 neutrons and 17 electrons. 17 protons, 17 electrons and 18 neutrons. Chlorine also has isotopes. So we see some isotopes of chlorine having 18 neutrons. Some isotopes of chlorine will have 20 neutrons. We'll come to that later. So what is the electronic configuration of chlorine atom? The electronic configuration of chlorine atom is 2, 8, that takes care of 10. So we are left with how many electrons now? 7. So 7 electrons will be there in the outermost shell. Okay children, now we'll see the next one. That's an ion. So we finished with all atomic structures of some elements that you have to study for this year. Now let us see what is an ion. What is an ion? When you talk of an atom, okay, we have seen different number of electrons in the last shell. There is a tendency of the elements to have either 2 electrons in its first shell, if it is just a 2-shelled element, if it has just 1 shell or 2 shells. Either it will try to maintain only 2 electrons in the first shell, this is called the law of duplet, or it will try and have 8 electrons in its last shell. This is also called the configuration of a noble gas. So all elements try to get the configuration of a noble gas. In order to do that, they either lose electrons or they gain electrons. Either an atom tries to lose an electron or it tries to gain an electron to complete its duplet or its octet. Either to complete its duplet or its octet. So this process of formation of ions, that is by losing electron or gaining of electrons, is called as, so it's called as ionization. So a cation is a positively charged ion. Why it is positively charged? It has lost an electron and hence it has formed a positive ion. Whereas an anion is larger in size. Why it is larger in size? It has gained an electron. And that's why, and since it has gained an electron, it is negatively charged. Electrons are negatively charged. So this is the formation of cation or anion. A neutral atom either loses electron to form a cation or gains electron to form an anion.